Imagine a world where voices never die. A world where a phone call could reconnect you with a loved one long gone, bringing their voice back to life in a way that feels almost magical. This is the promise and peril of AI voice cloning, a technology rapidly transforming how we interact with sound, making it possible to hear voices from the past as if they were right beside us. No longer the stuff of science fiction, AI can now capture the nuances of a human voice, replicating its timbre, pitch, and even emotional inflection with astonishing precision. This ability to recreate voices with stunning accuracy opens up a universe of possibilities, from entertainment to education. Imagine historical figures narrating their own biographies, or iconic actors continuing to star in films long after they've passed, their voices preserved for future generations. The potential applications seem limitless, touching entertainment, education, and even our personal lives in profound ways. But this brave new world of synthesized sound comes with its own set of challenges and ethical dilemmas. As we marvel at the ability to recreate voices, we must also grapple with the ethical implications of such power, considering the potential for misuse. How do we ensure the responsible use of this technology? What safeguards must be in place to prevent misuse and protect individuals' privacy? These are questions we must confront as AI voice cloning becomes increasingly sophisticated and integrated into our daily lives. At the heart of AI voice cloning lies a fascinating interplay of data and algorithms, a complex dance that brings artificial voices to life. Think of it as a cosmic dance, where data points and algorithms move in harmony. Vast amounts of data are spun and twirled into a coherent form, much like a choreographed performance. This dance is choreographed by neural networks, which are complex systems modeled after the human brain's intricate structure. These networks consist of interconnected nodes, each processing information and passing it along to its neighbors, creating a web of knowledge. The learning process begins by feeding the neural network a massive diet of audio data, which serves as its training ground. This could be hours of recordings from a single person or a diverse data set of many voices, each contributing to the network's learning. The network then analyzes these recordings, breaking them down into minute details, the rise and fall of intonation, the subtle pauses between words, and the rhythm of speech. It identifies the unique characteristics that make each voice distinct, much like a fingerprint. Through a process called deep learning, the network begins to recognize patterns and relationships within the data, forming a deeper understanding. It learns how different sounds combine to form words, and how these words convey meaning. It also learns how emotions influence vocal delivery, adding depth and nuance to speech. Each person's voice is unique, as distinctive as a fingerprint, and the AI learns to replicate this uniqueness. The more data it consumes, the more refined its understanding becomes, allowing it to generate more accurate and lifelike voices. Imagine trying to rebuild a dinosaur from a single bone. It's a daunting task that requires immense knowledge and creativity. That's the challenge facing AI when tasked with cloning a voice from limited data. The process is intricate and requires a deep understanding of vocal nuances. But just as paleontologists use their knowledge of anatomy to fill in the gaps, AI scientists use their expertise in speech patterns to reconstruct voices. AI leverages its understanding of speech patterns and vocal characteristics to recreate voices from even the smallest fragments of audio. This involves complex algorithms and machine learning techniques. This process begins with a seed recording, even a short clip of just a few seconds. The AI needs only a tiny sample to start its work. The AI analyzes this seed, dissecting its acoustic properties, the frequency spectrum, the rhythm of speech, the unique vocal tics that make it distinct. Every detail is crucial. This analysis forms the foundation upon which the cloned voice will be built. It's like laying the first bricks of a complex structure. The AI then draws upon its vast knowledge base of speech patterns, learned from countless hours of audio data. This extensive database is its treasure trove. It uses this knowledge to extrapolate from the seed recording, filling in the missing pieces, and generating new audio that matches the original voice. The process is both art and science. The result is an eerily accurate recreation, capable of speaking new words and phrases with the same intonation and emotional range as the original speaker. It's a remarkable blend of technology and human ingenuity.